Stewart does something weird where he lumps together, or they, I don't know, it's apparently a whole consortium of authors who work on these textbooks, lumps together economics and biology applications in the same section, which I don't really understand, but so we're going to do that. This is section 8.4, and we're going to talk about consumer surplus. So our objective here is to define and calculate consumer surplus using integration. So some very rudimentary economics that we're going to talk about here. So some of these words we use in passing and in imprecise forms. But here we're going to try to more or less break it down to fundamentals. So the idea here, though, is we want to think about any commodity that's sold in the market. And by that we mean something that is a good that is sold for at a specific price in a marketplace that is anywhere, like it is for sale in the US and is available to people in the US. And it's sold at a price that's determined by demand. So if there is a demand for a certain amount of units, then the price can go up or down depending on the demand. And this is what was typically referred to as the law of supply and demand. Now, to pin this down, to think about something concrete, think of, for instance, the commodity could be something like the iPhone 13 Pro Max, which no one needs, but is something that is sold for profit, and somebody's going to buy it, right? Maybe you, maybe me, not me, but maybe you. And it's sold at a price currently, and I had to dig for the price, but they are not super upfront about it, Apple. It's $1,099 per unit, okay? So you purchase one at this price, and that's given, the amount of units that have been produced. And I don't know the exact number, but I'm going to assume something along the lines of 100 million units produced. That's how much people want, okay? Based on what Apple thinks is the market for this new iPhone, right? So demand is in turn intimately related to supply, right? The price is ideally determined by the equilibrium in which the demand equals the supply. So there's a demand for 100 million units, and Apple can provide 100 million units. So really, demand is a function of X units and decreasing as a function of X with a current selling price of capital P equals little p of capital X, where X is the current supply. So again, if there's currently 100 million units, there's a price that is fixed by that demand. And if people want more, then the price goes up. If people want less of it, then the price goes down. So roughly, you can think of this as, it looks like a curve. So this is what I'm going to draw as the demand curve. Oops. Looks something like this. And at some point, it reaches the equilibrium, which is we've met demand with a fixed supply, and we can travel up or down that curve depending on how much supply. But here's the rub. So this is the price that's determined by our current state, okay? So we define consumer surplus to be the difference between how much a consumer is willing to pay and the actual cost, okay? Between how much people are willing to pay and the current cost, or price, I should say. So in other words, that is actually this integral. Because, this is P of little x, and this is capital P, and consumer surplus is defined to be the integral from 0 to x, capital X, of the difference between little p of x and capital P dx, okay? One way to interpret this is it's the amount of money that consumers save in purchasing the iPhone at its current price instead of the startup price before reaching equilibrium. So in other words, we know that it costs more to produce that first unit than to produce individually each one 100 million units, okay? It's a law of the startup costs, manufacturing costs. So what we want to think about here is we define consumer surplus of the iPhone 13 Pro Max as the amount of savings to the consumer by buying at the current price as opposed to being one of the first customers at the very beginning of production, okay? Note, this does not apply to commodities that are not subject to the law of demand, of supply and demand, okay? Artificial price setting is in play with items that are necessary to life. For instance, you could not use this model, or at least not in its current state, to model, for instance, the insulin market or the water market. All right, but let's see an example just for the sake of illustration, okay? So, a demand curve is given by P of x equals 450 over x plus 8. Find the consumer surplus when the selling price is 10. And we're assuming US dollars, but it could be anything. This is irrespective of the market, irrespective of the exchange. All right, so what do we know? What we're working with here is that we know we're given that our capital P is 10. We'd need to find the supply at the current state. So supply at current state is given by solving the equation 10 equals 450 over x plus 8. And that's going to be a capital X plus 8. Because it's a fixed value here that we're talking about. Okay, so we're going to solve that equation. We're going to flip the numerator on one side with the denominator of the other side, which ends up giving us 450 over 10, which means x plus 8 equals 45. So this capital X is 37 units. And who knows whatever this is, right? This could be like MRI machines or something. Then the consumer surplus, in that market, the consumer would be, say, hospitals or hospital administrators, right? Consumer surplus is going to be the integral from 0 to 37. So we're integrating with respect to the supply of 450 over x plus 8 minus 10 dx. Okay, now notice then that if we have this integral set up, we assume that the demand curve is going to be decreasing down to 10. We can reasonably assume this here. We don't need to probe this any further. So if we integrate this, we get 450 natural log of x plus 8 minus 10x, evaluated from 0 to 37. And then plug in a whole bunch of stuff here, right? You end up with 450 times the natural log of 45 over 8 minus 370 in whatever currency you happen to be talking about. Okay, so consumer surplus, there's not much more to say about that. In the next video, we move on to biology applications.